So guys, today we will see the loading of the data, EDA methods, data analysis, missing value, imputation and outliers treatment. So I have this Jupyter file, new file, YouTube video, and we have one data set, Titanic spaceship, that I have taken from the Kaggle. So what I will do, I will not directly load this data, upload it on GitHub, and then from there I will upload it. So first I will just import the libraries. Okay, then we'll go to the GitHub. Okay, so we will load in here. We will do commit changes. Then this is our data. We will click on the raw and just take this, and this is our file path. So now we will take df is equal to pt dot read underscore csv, and we will take file path. Okay, so this is our data. I have taken this from GitHub. I have shown you. This is good because if you want to move this file somewhere else, or you want to give it to someone, then it's very good. You don't have to give the data again and again, or you don't have to search for the data and upload the data. So once you have decided this file path, then you can load it from anywhere from any computer. First we will check data dot shape. So first we will check data dot df dot shape, and there are 4277 rows and 13 column. So there are 4277 rows and 13 column. And okay, for checking the missing number, there are many methods, but with this is I found good. This import library that is named as missing number, and then missing number dot matrix, and we pass our data, and label is equal to true. Okay, so you have good graph. You can see home planet and cryo sleep. In every column there are the missing values except the passengers IDs. So there is one method, and we will see the another method also. So we can check df dot is null dot sum. Okay, so you can see the number of the missing values. If I do the mean in place of sum, then you get the percentage, and we will multiply it by 100. And we can also just pass this in the data frame, and we can make it in the variable. So we can check here. So you can see we can do the sort values also. Y equal to, we can pass 0. Okay, so percentage of the missing value we have sorted, and we can see food court, spa and cabin, and almost everything has 2% of the missing value. Okay, now we will see the column, and we will segregate the numerical and categorical column. So for that, we first had to see df.info, and you can see all the columns. These are object column and these are float. Okay, object and float. Okay, the two types of column only. If we, okay, now we will check describe function. Okay, so you can see mean, standard deviation, minimum 25 percentile, 50 percentile and 75 percentile of the all numeric column. So if we here just pass include all, then you see the categorical column also. If we do transpose T, then you see column will come here and all the value come here. So whenever way you want, you can check it. So now what we will do, we will make two list of columns, two data, in which one will be the categorical and other will be the numerical. So what we will do, we will check, we see right categorical data is equal to df dot select d types and include is equal to object. And for numerical data, select type and exclude is equal to object. Okay, so now we will see seven columns are here, and 6 are here, so total 13. What was our initial 13 column? But one thing you see that cryo sleep, this is boolean, true and false here. So what we will do, we can make, if you want, we can make 3 columns. So we can include here exclude object and bool, comma bool, okay. So we here do here include object, and we will do exclude is equal to bool, just comma, still 4, 7 and 6, so total 13 column. So actually it's not coming because this cryo sleep is object type, so it's not the boolean category. So that's why 7 and 13, if we check dot columns, so cryo sleep is coming in the object categorical column. So what we will do, we will just change this type of the cryo sleep. So we will take this cryo sleep df dot as type bool. So now if we run, so now it will come 6 columns. So now you can see in categorical column cache sleep is not there, but for the time being I'm not doing the EDA analysis, so I will just make only 2 column. I will not create third column. If you want, you can create bool dot data is equal to, and you can just copy paste and just include. So if you check this, so it's here, but for the time being I will be creating 2 column only. So I will just remove this, and here also I will create bool also. So include object comma, now I have to write actually bool also here. So now you can see 7 and 6 columns are there. So so total 13 column are now divided into the 7 and 6 column. So we'll just comment out this, and for the time being I will just run all the cell so that there is not any error. Okay, so now we will see how to remove the outliers. So what we will do, we will just plot the box plot, and we'll see for I in categorical column. Okay, for box plot we require numerical column, so we'll just change numerical data, and we write SNS dot box plot and df. So we write here numerical dot columns df dot I, and we have to write also plt dot show to see all the graph. Okay, so you can see all the plots, age, room service. We are getting some warning here, only position argument passing not explicit. Okay, so we have to pass x is equal to this. So you can see all the plots, box plots, and these are the outliers. Okay, so and this is a good method. You can also for the categorical column you can also plot the bar plot. So just copy and paste, and we have to see here categorical data dot column xns dot so you can see you can also plot bar plot against the age. You cannot see too much in the cabin column, but you can see where the columns are very less, there you can see against the age or against anything. You can, if you want, you can check it. Okay, for filling the NA value there are many methods. There are mean, median, mode. There are many methods, but you can go whatever you like. But I always most of the time we go with the median, because of the outliers, mean will be very different. So I'm not going to fill here all the missing value. I will just fill up all the missing value from the sklearn using the simple imputer. So what I will do, from sk learn dot impute import simple imputer. Okay, but before that we will make the one list of the columns. I will tell you by, so column 1 is equal to list of df dot columns. Okay, so we can see all the columns here are here 13 columns. So here what we will do, we will make one instance what we have imported, a simple imputer. So we'll just make one instance of the name as imputer. So we'll do control B, and we will use strategy. So if you see the documentation, we can fill the NA value in 3 methods. So one is the mean, other is median, and other is the most frequent. So I will use here most frequent. You can use median also, mean, median. Okay, then if you want you can change it to the new data. So I will just rename it data 1, that is the df we use the data is equal to imputer dot fit underscore transform, and we will pass the df, and here we have to pass columns is equal to col1, because if I do not import this column defined here, column 1 equal to col1, then all the columns will be converted into the 0, 1, 2, 3, 4. So I will write here, I will just convert into the data frame, pd dot data frame, and okay, we have got error. Okay, okay, so now we can check data dot head. So there should not be any missing value now. We can check again dot is null dot sum. So see, all the values are filled now. So you can use your judgment how you want to fill the missing values here. So this is the one method of filling the missing values. There are many other methods. You can use ffill, bfill, subsets. There are many other methods. You can use that. Okay, so now we will work for the outliers. So suppose we take box plot, and okay, so we'll take age is okay. Okay, so let's we will take any column you can take. We will take age. So df dot age and dot describe. Okay, so mean age is 28 and max age is 79. So here your judgment is very, very important, because you see the age maximum value is 79 and minimum is 0, because it will be 0 point some 1 month or 2 months child will be there. So this is actually not an outlier. There will, because this 75 percentile means 75% of the people are below 37 age. So there is possible, because old people are travel very less. So it will be possible that there are the few person who has olden age 60, 70 or close to 80. So I don't think there are any outliers in the age. So we will just go to the food part. Food code we will see. Okay, so for outliers, domain knowledge is very, very important, because here you see if for age factor we know, but in the food court we don't know, so you have to read the document a lot and you have to consult the people. But here I'm just discussing, if in case you want to remove the outliers, how will you remove? So I'm not worried about it is correct or incorrect, because here I can see 75% of the data is below 78 and maximum is 25273, so there is something wrong. So what is the, how we will remove the outliers here? So what is the outlier? It is the Q3 plus 1.5 times of the IQR. So what is Q3? So I will tell you, Q1 is equal to Q1, Q2 and Q3. So Q1 is 25 percentile, so it's 0.0, and Q2 is 50 percentile, we don't require, but we'll take 0.0, and Q3 is 78. So what is IQR? IQR is equal to Q3 minus plus 1.5 IQR. We will just and upper bound equal to Q3 plus 1.5 into IQR. So this is IQR is Q3 minus Q1. So this is lower bound is Q3 minus. So we can see upper bound and lower bound. Actually we should do it opposite way. So lower bound limit you get 39 minus 39, and upper bound you have seen 195. So you see lower bound is valid up to minus 39, but we have 0. Kevin cannot be negative. So actually this is not the right data actually to see the outliers and removing the outliers. There is nothing below this, and there is everything outside the. Okay, so checking the value for upper bound and lower bound, we can just copy this and check. Okay, so we can see there is nothing below the lower bound, and you can check the upper bound also. You can see there are many value, around 800 900 value, which are the above the upper bound. But again I am saying this is not the correct data for remove the outliers, but we are learning the method, so it's okay. Okay, so for removing the outlier, what we will do, we will just write a use the np dot where. So what will be x is equal to np dot where x is greater than y, so there it will be y, otherwise will be x. So what this means, that this is very good function np dot where, so it will check if this is true, then this will come, otherwise this will come. Okay, so we will copy this food code, which is our x, and we replace x, and y is our upper bound limit, okay. So same thing we will write for the lower bound also. So here where this it is less than lower bound, it will become the lower bound, and this. Okay, but though here actually there is no lower bound, but I'm just showing you how we have to remove the outlier if it is less than minus 39 or something. So how you will remove? So you can give the, if you want you can give other value also, upper bound and lower bound. If you want to keep, don't want to keep up to IQR, you want to keep some more value, you can just give it there. But this is the standard method. Okay, so you can just see SNS dot box plot. of x equal to okay. So you can see now the beautiful box plot, there is no outliers now. So value starts from the 0 and goes maximum to the 178 something. Also we can write it to the function, because if there are more columns, then you don't have to write this function again and again. You have to keep the upper bound limit and lower bound limit. So we can write into the function. We can say def remove outliers, and we can pass here column, we can say cols, and now for I in cols. Okay, so what we do, we will just do the same thing which we done before. q1 is equal to df I describe 25 percentile, and same I will write for q3. q2 we don't require, so we will not write. I will write q3 only. So this is 75 percentile, and IQR will be q3 minus q1, and upper bound limit is equal to q3 plus 1.5 and IQR and lower bound will be q3 minus 1.5 IQR. Then again we will see, we will write this function only. We will change here data I np dot where data I is greater than upper bound, their upper bound, otherwise it will be the data I, and we write for the lower bound also less than lower bound, it will be the lower bound. Okay, so now our function is made. So suppose we want to remove the outlier sum df, you can take the numerical columns. What are the numerical columns? Numerical data dot columns. So we can column, right, col1 is equal to list, create a list, okay. So now if you want to apply the function, we have decided here pass the argument columns here. So in parameter, whatever columns you will pass, that the outlier will remove. So don't pass in the age, because now all the old people will be out already. So okay, if you want, already food code we have already applied. So suppose you want to apply, we will make new list, because we will not pass all the columns. So I will say cos2 is equal to, so we will pass room service, food court is already applied, okay, shopping mall, okay. As already said, this is not the actually correct data for removing the outliers, but we just learn how to remove the outliers. So I will take this function and we will pass cols2. Okay, so now all the outliers are removed from this column. So actually we can check for I in cols2 col2 plt SMS dot box plot, and x is equal to df equal to, and we have to write tlt dot show. Okay, so we can see there are the 4 columns: room service, shopping mall, spa, and VR deck. So this is room service, shopping mall, spa, and VR deck. You can see all the outliers are removed. Okay, so thank you very much. We'll see you next video.